Now, question number 3. A toy is in the form of a cone, radius 3.5 centimeter, mounted on a hemisphere of the same radius. The total height of the toy is 15.5 centimeter. Find the total surface area of the toy. Toy is in the shape of a form of a cone, radius 3 centimeter, 3.5 centimeter, mounted on a hemisphere. It is mounted on a hemisphere. Toy is like this shape. Hemisphere of same radius. Both radius of cone and hemisphere is equal to 3.5 centimeter. The total height of the toy is 15.5 centimeter. Here total height that we say capital H is equal to 15.5 centimeter. Find total surface area of toy. Here radius, both radius is equal to say, find H, here it is R, it is also R. Therefore, we say that H is equal to H plus R. Total height is equal to height of cone plus radius of hemisphere. Why we want height? Because we find in curved surface area of cone is equal to pi RL. We want L. For find N, we use small h. H is equal to H minus R. H is equal to 15.5 minus 3.5 is equal to 12 centimeter. H is equal to 12 centimeter. Height of the toy. Find the total surface area. We know total surface area like this, and it is. Then curved surface area of cone plus curved surface area of hemisphere. But curved surface area of cone is equal to pi r l. We want L. Then L is equal to under root r square plus h square. We use this formula for finding L. R square is equal to 3.5 square plus h square is equal to 12 square is equal to 3.5 square 12.25 plus 144. Sum of this number is equal to 156.25. Square root of 156.25, 12 13 is 156 is equal to 12.5 centimeter. L is equal to 12.5 centimeter. Now, total surface area of toy is equal to curved surface area of cone plus curved surface area of hemisphere. Toy is made up of combine of two shapes, cone and hemisphere. Curved surface area of cone, formula pi r l plus curved surface area of hemisphere, we use this formula 2 pi r square. Common part pi r l plus 2r. Now putting the value 22 by 7 into r. R is equal to 3.5 and is equal to 12.5 plus 2 into 0.5. Simplify. 22 into 7 5s are therefore 0.5. 0.5, 12.5 plus 2 into 3.5, 7.0. 22 5s are 110, 1 point is 11 into 12.5 plus 7.5, 19.5. Then multiply 11 into 19.5. 11 5s are 55, 5. 11 9s are 99 and 5. 104, 10, 11 1s are 11 and 10. 214.5 centimeter square. Then we say that total surface area of door is equal to 214.5 centimeter square. Okay. Toy is in the form of cone surmounted on hemisphere, centimeter mounted on hemisphere of same radius. Total height is equal to 15.5, radius is equal to 3.5. Then we find height of cone. Height of cone is equal to 12 centimeter, and then find length, slant length of cone is equal to 12.5, and using this formula, curved surface area of cone plus curved surface area of hemisphere, you should separately calculate this and add them. It is answer. Then answer is 214.5. Suppose you have not common, you do not common these terms, then you write calculate pi r l plus 2 pi r square and sum of these two terms. Then answer is also 214.5. In last year. Good morning. Exercise 13.1. Question number 4. A cubical block of 7 centimeter is surmounted by hemisphere. What is the greatest diameter the hemisphere can have? Find the surface area of the solid. Suppose we take in example, it is a cubical shape and surmounted hemispherical bowl. Then we calculate surface area of this sphere. This solid is equal to length, total surface area of hemisphere cube plus curved surface area of hemisphere minus area of base of hemisphere. In this question, a cubical block of 7 centimeter whose length is 7 centimeter surmounted by hemisphere. Q side A is equal to 7 centimeter. What is the greatest diameter of hemisphere can have? Suppose we put in cubical shape. Greatest diameter. What is greatest diameter? It is 7 centimeter. Then we say that greatest diameter is equal to the greatest diameter the hemisphere can have the greatest diameter the hemisphere is the hemisphere diameter is the hemisphere can have is equals to 7 centimeter. Diameter is equals to also greatest, then it is also 7 centimeter. Suppose the block is like this here, 7 hemisphere is also measure of this, then it is 7 centimeter. Length of this side is equals to 7 centimeter, then diameter is equals to 7 centimeter. Find the surface area of the solid. In example we show total surface area of solid or surface area of solid equals to surface area of solid is equals to surface area, outer surface area of cube plus curved surface area of hemisphere. It is like this. What is it? Is cube and this is hemisphere, then minus its base, then minus its base is equals to surface area of cube plus curved surface area of hemisphere minus surmounted by a hemisphere. What is the greatest diameter the hemisphere can have? 7 centimeter. Find the surface area of the solid, then minus base area, base 2 of hemisphere. Surface area of cube, side cube plus curved surface area of hemisphere. Formula 2 pi r square minus area base of hemisphere. Area base of hemisphere minus, it is circular shape, then pi r square. Area of circle is equal to pi r square. We write here a cube plus pi r square. 2 pi r square minus pi r square is equal to pi r square. R is equal to 7 by 2 centimeter. Here what is A? A is equal to 7 into 7 into 7 plus 22 by 7 into 7 by 2 into 7 by 2 equals to, no, here I write formula is wrong. Surface area of cube, I write here volume of cube. Right, surface area of cube is equal to, what is formula surface area of? 6a square. Okay, I write otherwise I write formula of volume of cube, then 6a square, sorry, plus 2 pi r square minus pi r square. Here 6a square plus pi r square. 6 7s are 42, 42 7 the 7 2s are 41, 7 4s are 28 and 1 29 plus 7 7 cut, 2 11s are 11 7s are 77 upon 2 is equal to 294 plus 2 3s are 6, 2 8s are 60, 38.5, 332.5 centimeter square. Then we write surface area of solid is equal to 332.5 centimeter square. Using formula properly, by mistake I take here cube of I write here formula of volume of cube, then a cube, but it is not here surface area of cube, then 6a square. Okay. Question: a cubical block of 7 cm is surmounted by hemisphere. What is greatest its diameter? Its diameter, how many greatest? It is 7 cm. Then diameter can have, hemisphere can have 7 cm. The hemisphere can find the surface area of solid cube. Here side is equal to 7 cm and radius of cube is equal to diameter 7 cm. Therefore radius is equal to 7 by 2 cm. Then 6l square plus 2 pi r square minus pi r square. Calculate this sum and simplify. 332.5 centimeter square. Now question number 5. You write this question in your notebook. Question number 5. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equal or to the edge of the cube is equal to the edge of cube. Determine the surface area of the remaining solid. Question number 5. A hemispherical depression is cut out from one face of a cubical wooden block such that the diameter L of the hemisphere is equals to the edge of cube. Determine the surface area of the remaining solid. Now hemispherical depression is cut out from one face of cubical wooden block. Suppose it is a cubical wooden block. Now cut off hemispherical space. Here cut off like this. Block such that the diameter L of the hemisphere is equal to the edge of the cube. Diameter of hemisphere is equal to edge of hemisphere. Diameter is equal to L. Then its length is equal to edge of hemisphere is equal to also L. Determine the surface area of the remaining solid. Now it is a total surface area of cube plus curved surface area of hemisphere minus area base of hemisphere. Then we write here L length side of cube is equal to L. Diameter of, in question we say that the diameter of hemisphere is equal to, diameter of hemisphere is equal to the edge of the cube is equal to length of side of cube or edge of cube. Therefore, diameter is equal to D is equal to L. Determine the surface area of remaining solid. D is equal to L. Therefore, radius is equal to R is equal to diameter divided by 2 is equal to. Therefore, R is equals to, what is the D? D is equals to L by 2. R is equals to L by 2. Now, surface area of remaining solid is equals to which two shapes are combined? Cube and hemisphere. Surface area of cube plus curved surface area of hemisphere. Which shape minus? Here in question, suppose it is then minus shape is equals to base of hemisphere minus surface area of base of hemisphere equals to surface area of cube is equals to L cube, A cube, side cube, you write here A cube. 6A square. Again, error. Surface area of cube is equals to 6A square. Plus curved surface area of hemisphere 2 pi r square. Minus surface area of base of hemisphere. Which type of base? Base is circular. Then area of circle is equals to pi r square. Then 6a square. 2 pi r square minus pi r square is equals to pi r square. Equals to 6. A is equals to, here side of cube is equals to A is equals to L. 6L square plus pi is in the form of pi. R is equals to L by 2 whole square is equals to 6L square plus pi L square by 4. Now LCM is equals to 4. 6 4s are 24 L square plus pi L square upon 4. Then we write common part L square by 4. Here remaining part 24 plus pi centimeter square. In textbook, they no put the value of pi. Therefore, as it is pi is equals to pi. Again, this question is hemispherical depression is cut out from one piece of cubical wooden block such that the diameter L of hemisphere is equals to the edge of the cube determine the surface area of remaining solid. Side of cube is equals to L. Diameter of hemisphere is equals to length of side of cube is equals to D is equals to L. But we want R. Radius is equals to diameter by 2. Then D is equals to L by 2. Now it is formula remaining solid is equals to surface area of cube plus surface area of hemisphere minus surface area of base of hemisphere. 6a square plus 2 pi r square minus pi r square, 6a square plus pi r square. Here 4 is LCM, 6 4s are 24 L square, L square by 4 common, then 624 plus pi centimeter square. Now question number 6.